yesterday was test day. If you didn't take yesterday's test because you just weren't here or something like that, get that done as soon as possible. Yeah. Okay. So then the next unit that we're going to start, we call it 5.3 to 5.6. There are 4 topics that will be in this particular unit, and those 4 topics are sum and differences of identities, or your sum and difference identities. Today, that's what we're going to focus in on, is the sum and difference identities. So you're going to want to have your identity sheet out with you. And then we'll do that today, tomorrow-ish. Then we're going to get into some double and half angle identities. And then we're getting into the law of sines and the law of cosines again. And we're going to expand on that knowledge from when you had law of sines and law of cosines in geometry. Okay? Next week, Friday, not this week, Friday, but Friday the 21st is Battle Royale Friday. And so Battle Royale is in the morning. We are planning on giving a formative that Friday. So if you have Schmeling 5 through 6 on Fridays, you will need to come in at some point in time or come into the Resource Center that day to get your formative done. Okay? So just so you are aware of that, we'll keep reminding you of that as we go on. Typically, they always tell us by like around 10 o'clock. Usually it's 2 hours long, but they really don't know until that week kind of deal. So, yeah. Okay. All right. 2 warm-up problems for you. I believe there's only 2 on this page. Okay, yep, good. 2 warm-up problems for you to do. Go. First one should be x squared plus 10x plus 25. If you just gave me x squared plus 25, you did Hall of Fame algebraic blunder number 1. Okay? Right? Those are the ones that are in the Hall of Shame. Shouldn't even be Hall of Fame. It should be Hall of Shame on those. Okay? On this one, it should be the square root of 25, which gives you 5 there, not 7. Okay? So we talk about these for a reason. Okay? And the reason that we're talking about these is because we've got those Hall of Fame algebraic blunders. Okay? But so we want to see if that transfers over into trig. So today what we're going to be doing is we are going to be adding and subtracting angles together and then taking the sine of that. And this does not just mean, so the sine of u plus v, so we got an angle here, that doesn't mean I take the sine of u and I add it to the sine of v. Okay? We're going to be off of our identity sheet today, and we're going to be dealing with numbers 18, 19, and 20 on your identity sheet. So if you'll notice, it's a little more complicated than just taking the sine of the first angle and adding it to the sine of the second angle. Okay? So we've got actual formulas that we need to work on. Okay? And so those actual formulas then are here. Here is how they are written out without the pluses and the minuses, just so you know, except for tangent. Tangent, we didn't want to write out that fraction twice. Okay? So cosine is cosine, sine, and it's opposite the symbol. So if you're subtracting the angle there, then you're adding the co and sine. Okay? Truth be told, I didn't memorize 18, 19, and 20. I memorized the pattern. Okay? To make it easier on me. Okay? But that was just me. Okay? Sine is same sign. Okay, easy to remember. Same sign. So if it's subtraction there, it's subtraction there. If it's addition, then it's addition. Okay? Cosine is opposite. Sine is the same. And sine then is sine of the first, cosine of the second, cosine of the first, sine of the second. Cosine is sine, sine. Tangent in number 20 is tangent of the first, tangent of the second, same sign, but then it's it's opposite sign here. So if you're adding on the top, because you're adding in the angles, then it's subtracting on the bottom. Okay? Awesome sauce. Let's put these to use. I don't think that there's one below this. Sometimes oh, good. Okay. So what this allows us to do is this allows us to find non-sweet 16 unit circle angles. Okay? For instance, 75 degrees is not on the unit circle. Okay? So, what two unit circle angles are add or subtract to give me 75? 15 is not on the unit circle. 45 and 30 works out though, if I add them. So this could be the cosine of 45 degrees plus 30 degrees. Give me a subtraction one. Two unit circle angles that subtract to be 75. 135 and 60. Okay. We'll do this both ways, okay? Just to show you that it doesn't matter if we add or if we subtract. So we're using cosine. Cosine is identity number 18 on your sheet. Okay? So the cosine of u plus v says then that I am going to take the cosine of 45 degrees. I'm going to multiply it with the cosine of 30 degrees. Then I am going to subtract, because my mathematical operation is different, the sine of 45 degrees times the sine of 30 degrees. Yes? Okay. What is the cosine at 45 degrees? Square root 2 over 2. What is the cosine at 30 degrees? Square root 3 over 2. What is the sine at 45 degrees? And the sine at 30 degrees. Square root 2 over 2 times square root 3 over 2. Square root 2 over 2 times square root 3 over 2. What do we got? I do not like root 5 over 4. Square root of 6 over 4. Square root of 2 over 2 times 1/2. Square root of 2 over 2. Let's see, square root of 2 over 4. Okay. Can I combine those fractions? Yes, into what? No. No. Good try though. Square root of 6 minus the square root of 2 all over 4. Thank you. Can I simplify it any further? Nope. Okay. So that would be what it is. Okay. You now try the green one. Try the cosine of 135 minus 60. Utilizing that formula should get square root of 6 minus the square root of 2 all over 4. So this is going to be the cosine of 135 degrees times the cosine of 60 degrees plus this time now. Better plus, better plus. Come on, Linz, make a better plus. Plus here, the sine of 135 degrees times the sine of 60 degrees. The cosine at 135 degrees is negative root 2 over 2. The cosine at 60 degrees is 1/2. The sine at 135 degrees is the square root of 2 over 2. And the sine at 60 degrees is the square root of 3 over 2. That gives me negative square root 2 over 4 plus the square root of 6 over 4. So over on this side, I get the cosine of 75 degrees is negative square root of 2 plus the square root of 6 all over 4. Are those, in fact, the same? Yeah, because order doesn't matter in addition, right? So we could write that in either method. Yeah. But no matter what we do, if we added it or if we subtracted it to get 75 degrees, we get the same answer. As we should, because it's the same angle. Let's switch now to radian measures. This works both in degrees and in radians. Okay. Okay. So we have the sine of 5 pi over 12. Okay. So 5 pi over 12, obviously not on the unit circle. So there's that. Okay. So what can I do? We could do the sine of, let's see, what adds together to be 5? 2 and 3? 3 pi over 12, right? What does that reduce to? Pi over 4. Okay, so that's on the unit circle. 2 pi over 12. Pi over 6. Both of those are. Yep, so we could do 3 pi over 12 plus 2 pi over 12. And that would be the same as the sine. Oops, here, let me put this down here. That would be the same as the sine of pi over 4 plus pi over 6. Yes? Okay. Give me 2 that subtract to be 5 pi over 12. Six and 1 wouldn't work because 1 pi over 12 isn't down there. 8 pi over 12 and 3 pi over 12. That works. Okay. Because then that one becomes 2 pi over 3 minus pi over 4. Yes? Nine pi over 12 minus 4 pi over 12 would also work there. 3 pi over 4 minus pi over 3. Okay? All right, so let's do blue then. Sine is, this is number 19 now on there. So we've got the sine of pi over 4 times the cosine of pi over 6. The SIGN in between is the same, so that's plus, or the operation I should say. Then cosine of pi over 4 sine of pi over 6. Sine at pi over 4. Square root 2 over 2. Cosine at pi over 6. Square root 3 over 2. Cosine at pi over 4. Square root 2 over 2. Sine at pi over 6 is 1/2. This gives me the square root of 6 over 4. This gives me the square root of 2 over 4. So the sine at 5 pi over 12 is equal to the square root of 6 plus the square root of 2 all over 4. Yes? Yeah. Okay. You find me green. Sine at 2 pi over 3 is the square root of 3 over 2. Cosine at pi over 4 is square root of 2 over 2. Cosine at 2 pi over 3 is negative 1/2. Sine at pi over 4 is square root of 2 over 2. So then this gives me the square root of 6 over 4 minus negative square root 2 over 4. So then this gives me the square root of 6 plus the square root of 2 all over 4. which is exactly the same. Okay? You now try the tangent at 11 pi over 12. I don't care if you do it via addition or subtraction. You try that one. Now, this by no means is the only pair that works. Okay? 8 pi over 12 plus 3 pi over 12. Okay? Okay? So this is the tangent of 2 pi over 3 plus the tangent of pi over 4. Okay? Out of curiosity, and just to make it easier on ourselves, what is the tangent at 2 pi over 3? Negative square root of 3? Everybody agree with negative square root of 3? Okay. What is the tangent at pi over 4? One. Okay. Right. Makes it easier when we go into the formula. Into the formula says tangent of pi over 3, tangent of 2 pi over 3 plus the tangent of pi over 4 all over 1 minus the tangent of 2 pi over 3, the tangent of pi over 4. So that would be then negative square root of 3 plus 1 all over 1 minus negative square root of 3 times 1. Yes? Okay. So then that's going to be 1 minus the square root of 3 all over 1 plus the square root of 3. Do you agree with that so far? For these, we are asking that you rationalize the denominator. So in order to rationalize the denominators, we have to multiply by the conjugates. Okay? So on top then, we get 1 minus the square root of 3 minus the square root of 3 plus 3. On the bottom, we get 1 minus the square root of 3 plus the square root of 3 minus 3. So the tangent of 11 pi over 12 should be 4 minus 2 square roots of 3 all over negative 2. Do I like that? I don't like that. Nope. I do not like that. So I'm going to change this whole thing to, I'm going back to blue on that one. We're going to go that one on that one. Yep. Yep. Don't like it. Yep. Switch the colors. Okay, so what do I like instead? What do I like instead? Don't even like that one. -2 plus the square root of 3. Because 4 can be divided by -2, and -2 can be divided by -2. Yes, ma'am. You're going to get -2 plus the square root of 3. Promise. No? I'll look at it in a minute. Okay? The other style of problem that we're going to give you goes backwards. Okay? So here is more identifying which one you're dealing with. Cosine, cosine plus sine, sine. Which one is that one? 18, 19, or 20? 18, so that's cosine, right? Cosine, cosine is cosine. Is this a cosine plus, or is this a cosine minus? We know that it's going to be cosine of 42 and 12. Is it going to be plus or minus? Minus, okay. What is 42 minus 12? 30, so this is the cosine of 30. And what is the cosine at 30 degrees? Square root of 3 over 2. So this one is the square root of 3 over 2. Next one. Is it sine, cosine, or tangent? Sine. Okay. Is it sine plus or sine minus? Sine plus. What is the sine of 7y plus 3y? Sine of 10y? Next one. Bugging me that that B is not capitalized right there. Now hopefully the equation will go all. There we go. I like that better. Okay. We've got tangent of 3b and 2b. Is it adding or subtracting? Subtracting. 3b minus 2b then is b. So this is just the tangent of b. Okay? pause here. So, with double and half angles. So this is identity number 21 on your sheet. Okay? So the sine of 2u would be the sine of u plus u. Correct? Yes? 2u is equal to u plus u. Okay? Now I can use what we just learned. The sine of u plus u would be number 19. So number 19, identity 19, would say that this is the sine of u cosine of u plus the cosine of u sine of u. Agree? Does order matter in terms of multiplication? No, it doesn't. So sine of u cosine of u is the same as cosine of u sine of u. So if I got one of them and you give me another one, how many do we have? We've got two of them. So we've got 2 sine of u cosine of u, which is the identity. Okay? Your job now, for the remainder of class, is to dive into the identities and find the trig values when you double or half the size of the angle. So, for sure, tomorrow you need to have the front side of this packet done. Okay? For tomorrow. Okay? If you keep going, keep going. Okay? But you got time to work now on it.